Thank you everyone for joining Teledyne ISCO's September Pumps webinar, focusing on a discussion on difficult applications. Today's webinar will be led by Nick Daddabbo, Pumps Product Line Manager. If you have any questions or comments throughout the webinar, please use the chat function within the application. All questions will be answered at the end of the webinar. At this time, I will turn it over to Nick.
Thank you, everybody, for dialing in and listening to our discussion on difficult applications. The centered focus of this presentation is zooming in on the pump itself and the role it plays in designing out applications and chemical reaction experiments, etc., and tying in things you need to consider from the layout or the lab itself, the lab setting, and potential non-normal types of things you need to consider. And we'll talk about that in just a few minutes. Let me introduce myself real quickly. I am the Pumps Product Line Manager for Teledyne ISCO. I have been in product line management for over 17 years with companies like Xylem, Goulds, Hydex, and SPX. I've spent about 12 of those years in the pump business. I did spend some time with mixers and industrial mixers, but mostly for those 17 plus years, I've been focused in oil and gas, pharmaceuticals, chemical, and food and beverage markets. I bring a variety of pump knowledge to the table. I've been experienced with pumps in the production side, in process, in R&D, and in scale and pilot. So I've had the full gamut of experience across the table here. So we will start out this discussion talking about two types of pump technologies. And to be fair, there are many different types of pumps in the pumping technologies. You can have peristaltic, you have diaphragm, you have gear, you have rotating pumps, you have centrifugal, you have multi-stage pumps. The pumps world is large and expansive. We're going to kind of just talk about these two types of pumping technology today, and we're going to reference them throughout the presentation. So the first pumping technology we're going to talk about is syringe pump technology. And when we talk about syringe pump technology, we're not speaking about the tabletop type that Harvard Apparatus or KD Scientific do. We are speaking more of the larger syringe pumps like ourselves, Teledyne ISCO, Quizix, etc. Some key things that when you're looking at syringe pump technology, you want to keep in mind. There are significant advantages. First and foremost is it's a long-lasting design. Because it's a long-lasting design, there may be some the investment might be higher to start, but the long-term ROI is very quick. Most of the time, these syringe pumps can work, once you install them, can work 20 to 25 years with just normal maintenance. And we've seen that specifically with our pumps for sure. Another key feature of syringe pumps is pulseless flow. Pulsation can be bad and can change the chemical characteristics of the material during the chemical reaction. It can also have an impact on the amount that's dosed out, etc. So when you're looking at something that has that sensitivity, you need to be sure you find a pump or a pumping technology that can handle the least amount of pulsation as possible. Syringe pump technology is as close as you will get to complete pulseless flow. Another benefit of syringe pumps is the preciseness of the flows. You will see many times, and you look at our pumps for sure, they can get down to 0.5% of accuracy, 0.3% of accuracy, 0.2% of accuracy. Those are very, very precise flows. And with that, you also have the capability to get to higher pressures. Now, it depends on the industry you're in, but you can get up to 30,000, even in some cases 35,000 PSI. That's a lot of pressure. I'm not saying that most applications use that, but if you so needed it, you can do it with a syringe pump technology. That design, the engineering scope of a syringe pump allows that to happen. Disadvantages, like we spoke about earlier, the initial investment is higher when compared to other pumping technologies, but the ROI is satisfied very quickly. Many times they're larger pumps, like they're not like your smaller tabletop ones. And when the preciseness of flow from a syringe pump is lots of times dependent upon the smoothness and the fineness of the inside of the syringe cylinder. And you would not want to use large particulates in this case. It could probably handle it, but it might scrape the inside of the cylinder and potentially impact the ability to pump at such a great rate, fine rate or precise rate. And also, the scratch cylinders and it will reduce the performance life of the syringe pump technology. The next type of pump that we'll talk about is reciprocating pump. Now, this is very simple. We saw reciprocating pumps when we were young kids, when we saw the little trains with the moving wheels and the bar turning the wheels. This is the same type of technology. It's really just you have a stepper-driven gear that pulls back the piston, and you'll see in the diagram there, it'll pull the fluid in the inlet on the suction phase, and then the next movement is the discharge, where the piston pushes the pressure back out and pushes the fluid out the outlet. And you have check valves that shut off the inlet and outlet during each time. Some of the drawbacks of reciprocating pumps is check valves can be kind of messy sometimes. But yeah, if you're looking at that technology, you've taken that into consideration in your application design. So as we move forward here, one of the things that you want to look at is getting all the information you can and knowing as much as you can prior to selecting the type of pump you need for your chemical reaction experiment or your application that's in a lab setting. And so I want to walk through some questions here, and some of the following slides will have direct ties to these questions. So the first question we want to look at is what type of a process is, and really what that means is this an R&D, is this a scale pilot, is this actually going to be used for production? And in many cases, when you think of production, it could be a lab setting, or it could be micro batch production of a material. So you want to consider all of that. So first and foremost, you need to know where it's going, what type of an area. The next one you want to look at is how much room is there available for the pump to be installed. Now, that doesn't mean is there enough space for you to go do it and go set it up. What it means is if it's a small table, if it's a fume hood, today's fume hoods are very, very tight with all the different types of reactors, valves, and pumps that you put in them. It really gets cramped very fast. And safety is a big issue. So, you can cram a lot of equipment into a space, but it becomes an unsafe working area if you're not careful. So you want to look at this and you want to ask the question, does it have horizontal room? Does it have vertical room? And you want to roughly get the dimensions. When you're looking at a syringe pump, for the most part, they're much taller than other pumps. You can lay some on the side, so to speak, but they're much taller. So you want to have potentially vertical room. You also want to look at what your horizontal room is, and we'll explain why in just a few minutes. Is the fluid considered aggressive or corrosive? That obviously is number one, because the machine or the pump that you're using has to be able to handle it safely and not pump it for 3 days and then it starts to leak, right? Because leaking of aggressive or corrosive fluid is a significant safety hazard and a danger to everybody. Does the fluid need to be heated or cooled to maintain a constant temperature? Do you need to heat it to change its properties? These are things you want to understand because it has an impact on the type and style of pump that you consider. Here's one you should be pretty familiar with. Does your fluid have particulates? We just talked about what large particulates do to the inside of a syringe pump cylinder. This question directly goes to that. Right off of that, when you're talking about the material, the fluid that you're pumping, is what's the viscosity? Is it thick like mud? Is it very thin like water, or is it somewhere in between? You want to know that because it's going to affect the type and style of pump that you choose in the types of applications you put it in. Next, you want to understand if it's in a hazardous area and what the classification is of it and what the classification of the adjoining area is. In many cases, you can segregate parts of a lab into different areas, different hazardous areas, and you want to understand where this pump or this experiment is going to be. Because if the experiment design and layout has some flexibility, the pump doesn't necessarily have to be right in line with the process. Okay. And this goes to another thing: is where is the placement? Where's it going to be controlled from? Where is an operator going to be adjusting the fluid levels or adjusting the piston speed? Where are they going to do that from? Is it going to be right there sitting on the pump? Is it on a table next to it? Is it across the room? And all of these questions should be brought up in the aspect that you during the design phase, because you can help influence and potentially make the area more efficient and a better working area. Because I'm going to assume that majority of customers out there don't know that there's flexibility in some of these things. And when we bring that up, it should give them an idea, hey, okay, maybe we can move this over here or gain some space or whatever. Okay, so these are things, and there's a lot of other questions you would want to ask, but these are ones you want to, these would have some more connections to the later discussion. So you want to make sure you get these questions asked. You know, and just to be totally open and understanding, there are many, 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 many variations of when you're laying out an experiment. There's millions of different combinations. So just keep that in mind. All right. So now we're going to move into kind of the core of the presentation. And what this has to talk about is we're going to take specific pieces that are specialties, I'd say, of setting up when you're considering a pump or when you're considering purchasing a pump. You want to understand, you want to know if this is what they need, what the customer wants. Okay. So the first one is continuous flow. Very simple. Does the customer need the flow to be continuous and steady stream? Do they need a start and stop? And do they need pulseless, not pulseless? Because when you're looking at continuous flow, pulsation is definitely something that comes into play there, and they need to consider that. And then how much of a continuous flow? Are you going to be is it going to be just like a pass-through? You're going to have a large vat of something and it's going to move the fluid over to another vat of something else? Or is it timed? How long do you need the pumps to be running? Now, so if the problem is continuous flowing material, great. You can put two pumps together and you can have a continuous flow, or you can get dual-headed pumps that have continuous flow. So you definitely have options when you look at the style of pump. But a bit of a different twist is Teledyne ISCO has the ability with their controllers, their current day controller, to manage 4 pumps at a time. So if you can actually potentially design the experience to manage 4 of the pumps, you might be able to get more material through. You might get a better flow, and you could control it from one device, which is pretty exciting in some cases for some folks. We do have a tactical bulletin on our website that discusses all of that and how to set it up and how it acts. You can set it up so they're all in unison. So it goes flows 1, 2, 3, 4, piston 1, piston 2, piston 3, piston 4. You can do piston 2, piston 4, piston 1, piston 3, alternating. You can do 1 and 2, 3 and 4. There's many ways you can set them up to dose in material at specific times. So what you're looking at is you can have 4 pumps potentially dosing in 2 different types of materials within different time settings, and you would set that up on the controller that comes with the product. Great read, great opportunity, great flexibility we have in our pumps, sir. The other thing you want to look at when you look at continuous flow is the material, because if you obviously have a valve set up for continuous flow with 2 syringe pumps, and you need to be aware of the material that's going through there. So in air and electric and the advantages and disadvantages of that. We can get into that at another point, but there are some clear advantages and disadvantages. If you have any questions, just give us a yell for that, sure. There's also the single versus dual head pumps. If you have a single pump, you're gonna need 2 of them to do continuous flow for the most part. If you have a dual head pump and the 1 pump, you would have a single pump. Things to consider. We offer 2 similar pumps. The Reaxis LS and Reaxis LD are basically cousins of each other. The LD has a dual head and can go up to 10,000 PSI, and the LS has a single head and go up to 6,000 PSI, and both run at up to 100 milliliters a minute. Very similar. So continuous flow is something very easy to understand, something easy to figure out. If you need continuous flow and you got 1 pump, you buy another one. Or if you're buying your pumps, you buy 2 pumps instead of 1, or a dual-headed pump. So that's very easy to figure out. Moving on to the next scenario that comes into play here is a space constraints. You know, remember I talked about the size, getting dimensions and the size and the vertical and the horizontal height. Size is very important. Space constraints is happening all the time as we start to really grow and do more different things with our experiments, especially fume hoods. So Teledyne ISCO does have a couple options to manage that. And these are just options, and there's other potential options in the market, but let me just talk about these. First off, we have a version of a pump that's called a short pump. And it's only 2 feet tall, and it goes to about 3,750 PSI and about 204 milliliters a minute. You can do single pump or dual pump in that configuration, and that is our 500 SP. That is definitely, you get the full, pretty strong power of a syringe pump, but much smaller height to save you space. And there's a little picture in there upper right there you can look at. So this comes into play if you need to have a different spot or different setup in your fume hood area. You also have the ability, this is a pretty, I like this one, this is pretty exciting. The Teledyne ISCO syringe pumps, the D series, can be mounted upside down and can be mounted horizontally. And when we were talking about hazardous and non-hazardous areas, you could actually put the syringe in one area and have the box over here, and you have a wall or a barrier between the two. So we do have customers that mount our syringe pumps upside down and run them that way, and they've run that way for years and years, and they run with no issues. So, you know, I like to look at a box of having 6+ sides on it. It's not just a 4 square. So when you consider how you need to mount the pumps or where you need to mount the pumps, that's definitely an option for you. And the controller could be mounted to the box, or you could have it separately, and with something that we're going to talk about shortly. And then also, alternatively, you know, if you need smaller footprint space, you can look at our Reaxis line that we have. Those are much smaller footprints, right down from the M1 to the PR. So space is a big concern nowadays, and this helps. Knowing you have these options available will help you. Okay, so space constraints, continuous flow. Another scenario that we run into a lot, we hear about, is viscosity, the viscosity of a fluid. The problem is the material being pumped is very viscous, kind of thick and chewy and moving. What are the solutions we would recommend is maybe heat the fluid up before, during pumping or before, and or use a larger port opening. So looking at that and considering that, we have pumps out there that are considered, we call them high viscosity. And they're able to handle 300 centipoise, so motor oil consistency, up to molasses, which is a very large spread, but we can pump that out real easily with these pumps. And in those pumps also, we kind of did, the ports are 3/8 inch, sort of bigger than usual, allows for more viscous fluid to come in. And there you could have them with air valves, with 2 pumps, or even with a single pump. But secondarily, what I've seen other customers do and mention to me is they've also put heated jackets on the products themselves to heat the pump, to heat the cylinder, to change the material consistency or the viscosity of the fluid that you're pumping. And that will loosen it up. But in some cases, that could be an issue because the heating of the material could change the consistency or the actual properties of the material, and that can be a problem. So you need to consider that, and that's why we're asking. You want to ask earlier about is the fluid you're moving very viscous? That's an important consideration when you're looking at that, trying to lay it out or design an experiment. Okay. So we've talked about viscosity, we've talked about space constraints, we've talked about continuous flow. Viscosity is something that will come into play in a lot of different markets. Next, we want to move on to another consideration when you're looking at tougher applications, designing them, and that's corrosive materials. You know, the problem is pumping corrosive and aggressive materials. The solution is looking at different types of pump construction. There's many different variable material types out there. like Hastelloy and our syringe pumps and reactors have that capability. You can get titanium, you can get PEEK, you can get Teflon coating, all of that. And then different types of pumps and different types of companies handle that. But when you're looking at that, the first thing you want to consider, you want to look at is, the whole fluid path. You need to know the seal, you need to know the valves, all the wetted parts. Corrosive materials have a way of getting out and finding themselves out to somewhere if they are not completely protected by their fluid path. So you want to definitely consider that. And always, always, always take the time to check the corrosion chart for compatibility with the material you're dealing with and that you're ordering. That's a very, very important thing. You can get it ahead of the curve by doing that, because you'll be able to express or detail out to the customer, this is what you need. Or they'll tell you, and you go back and look at it in detail to the factory that you're buying it from, this is what I need. So corrosive materials is a consideration and can be a tougher application because some materials are much more aggressive than others, especially to certain types of material, pump materials or flow path materials, okay? The next one here is fluid structure. Now, fluid structure is the composition of the fluid that you're mixing. So one problem that comes out lots of times is trying to keep the materials in suspension while you're pumping. So that would require a bit of a vortex to keep the separation going on, or keep it kind of homogeneous. So we suggest you install a mixer onto the pumping cylinder. And we have a mixer package that goes out there for our 500D and our 1000D. And it's a specially designed impeller that fits within our cylinders and slides down into the holes on the cap before you put the cap on. And it doesn't go very far, but it creates enough of a vortex through the whole cylinder. And this will even work in a pump that's upside down. We've had customers actually using it in pumps that are upside down. It's pretty exciting. It's only an air-driven motor right now, so it's a little noisy at this point. But in the future, there will be options for more of an electric motor. If you want to learn a little more about that and how it's done, we have an application note, AN25, on our website. When you go to application notes under pumps, that actually kind of talks about this a little bit. But this is a feature that is becoming more and more requested as we go along. So, if you're not sure, how do you keep the suspension, how to keep the fluid in suspension in your process, we can work the mixer couples very well with the pump. So a couple other challenges that we run into and we see, and they're challenges, they're potential problems, but first off is there's no space to mount a controller. So there's options out there for the controllers that Teledyne ISCO offers. You can get a 50-foot cord or a 10-foot cord. Now, if you remember earlier, we were talking about mounting a pump upside down, and you could either mount the pump to the pump, mounting the controller to the pump, or have the controller down on the floor or on a table that's got the cord extended up to the pump. And this is where the 50-foot cord or the 10-foot cord comes into play. These are great ways to say, okay, I don't have enough space to put this controller and pump together. I need to move it somewhere. And literally what you just heard is you can take a pump, mount it upside down so it gets it off your table and it's above you, and have the controller another 10 or 15 feet away, and you've got plenty of space to deal with things. So that's a nice little piece, and if you have any questions on that, please ask us about that. And we talked about hazardous areas, corrosiveness and et cetera. You want to also look at where it's being mounted or where it's being set up. Is the area hazardous? And what is the classification? There's only certain classifications that we can work comfortably in. It does get challenging sometimes. We do have customers that have actually taken our pumps and put them in a hazardous location box, like from a stall or somebody like that, and mounted them in there. So it's protective and it's a very explosive hazardous area. I think Class 1 Div 1, it happens that way. But if it's just a general hazardous area, not one that's in the Class 1 Div 10, but maybe a Class 1 Div 2, we do have hazardous location pumps available that are set up in that arcing and sparking for use in those areas. But it can be challenging. Fitting something in an area that has a hazardous location rating can be difficult at times. So consider that, look at that, and think of all those pieces. So lastly, there's what we talked about today is just barely scratching the surface of all the different types of things that come up when designing an application or chemical reaction setup. And you want to really kind of take a look at, make sure you ask those questions and go back and look what I said. But there's additional resources out here available for you that I'm going to tell you about now. First and foremost, we're going to tell you on our Teledyne ISCO site, we have a bunch of technical bulletins and application notes that are available that kind of touch on a myriad of installations and things we've ran into over our years. So years and years of experience to pass along and notes and documentation of information for you to learn from. The next one, Google Scholar is an amazing resource for academic research conducted using pumps. You can type in syringe pump, hit search, and then you can narrow down how you want it. If you want syringe pumps in hazardous areas, you want something like that, or you want pumps, it's just you can probably spend days looking around Google Scholar and looking for information on the setup you're looking for and just what type of issue do you have. So you can go in there and say hazardous location and pumps. You can go in there and say space constraints and pumps, and it'll give you those different types of piece of information. And lastly, we have hundreds of years of engineering application development experience here at Teledyne ISCO, and I'm sure that that's probably true in a few other companies too. Do not ever be afraid to call the vendor or call the factory and ask them the questions and lay out the scenario you have. I know we can help you any way we possibly can, even if we have to tell you we can't do that, but these guys over here do. So with all the variations we talked about and all the different types of considerations you want to think about, there's some key pieces of places for information and reference as you need it. So now we're going to kind of open it up to questions and let us know if you have any questions or comments.
And as we move on to questions, I do want to let everyone know as well that this presentation will be shared with all attendees. You will be sent a link to download and view the presentation a few days after this webinar. So you will all have access to this presentation. And as always, if you have further questions or comments after we wrap up the webinar today, don't hesitate to reach out to us and we will make sure to get you to the right person to answer